Morning. This is slide 10, which I believe is where most of my classes left off yesterday. So slide 10, we are continuing along with the theme of is the law of conservation of energy broken? Um, but this is relating to the lab and the mixing of waters that we did last week. So question 15 here is pretty similar to question 11 on slide 8. But now question 15 is as I am pouring the cold water and room temperature water together, is heat being released or absorbed to the surrounding air? So the last one we looked at was hot water. Now we're looking at cold water here. So you want to think about, okay, is the air hotter or is the water hotter? And we know the direction of heat flow is always from hot to cold. So if it's going to the water, it would be absorbed. If it is going away from the water, the heat will be released. So hopefully that is enough to help with that one. Question 16, if the water is the system, is this an endothermic or exothermic heat transfer? So based on what your answer to number 15 was, if you put absorbed, then you need to figure out, okay, wait, is that endothermic or exothermic? And if you put released, is that endothermic or exothermic? If you don't know, you can look at 46G or you can use Google to figure out the difference between endo and exothermic heat transfer. And then question 17 is so would we expect the total energy before mix to be more or less than after the water is mixed? So very similar again to the set of questions on slide 8, and 18 is the same. Does the data on the following slide support your answer to the question above? So be referencing the numbers in box F and box G. Notice uh, these water samples, it is a room temperature one and a cold one. So just, that does go along with the scenario that we have going on in slide 10. Slide 12, what you are doing is answering this question. This is point being, what was the purpose of slides, it should say 7 through 11, basically. So why is the law of conservation of energy still followed, even though the total heat energy before mixing water was not always the same as the total heat energy after mixing the water? So just explain it a little bit, reflect back, look at the answer to your questions, and try and figure that out. And again, the law of conservation of energy is on slide 7, so that's where energy cannot be created or destroyed, only converted to one form or the other. So how is that still followed even though our energy numbers do change? That is what our point being is in our question. And then this is our last bit extension to last week. We have a scene. After mixing the hot and room temperature water, the water will sit on the counter for 5 days before I put everything away. Um, Assuming the system is a cup of mixed water, answer the following questions. So I want you to tell me what are the surroundings? As the hour goes by, what happens to the temperature of the water? Is the system, meaning is the cup of mixed water absorbing or releasing heat? And so then is the transfer of heat endo or exothermic? And then slide 14 here, you get 4 points of extra credit for this if you want to do it, great. If you don't, leave it blank. But it is making another scatter plot. And this time what you are doing is recreating the scatter plot from slide 5. So I gave you this one. You have to recreate it. Um, so pick one temperature and 4 different masses. Use that data to recreate the scatter plot on slide 5. Use Google if you need help. Insert your graph onto this slide. I will tell you, so on here, so I need one temperature and then 4 different masses. So on this one, I use mass 50, 100, 150, and 200. And my temperature was 19. So what I did for each of these would do 50 times 19, and then 100 times 19, and then 150 times 19, because the formula is mass times temperature equals heat energy. So if you're wanting to do this, how you get your data would be by multiplying each of your masses by the temperature, and then that gives you what your heat energy is. You put that in the little table, insert it, so on and so forth, just like how we did on slide 2. So if you are interested in that, do it, and then you do need to mess around a little bit, figure out how do you get these labels on here? How do you change the color of these dots? So on and that forth. So get those things consistent and replicated as well. Um, so that is all. Um, oh, actually, I will show you this too. So these are my general notes just to bring your attention here. So there are only 9 days of school left, 8 after today. That's not many. Quiz G, the last quiz will be next Monday. So we have Wednesday, Thursday, and then it'll be on Monday. Well, and then Friday, but Friday is the retakes and makeup anyways. If you're needing to make up one quiz, do that on Friday. If you need to make up multiple quizzes, you need to be emailing me to set up days and times to do so. You are only allowed to make up one quiz per day. You can't just come for an hour and knock 5 out. Nope. You need to only one per day because you need to study beforehand. You need to be ready. You need to say, okay, Miss Sunday, like on Thursday, I want to take quiz C. I have studied or I am looking at the assignments. And this is the one I am prepared for. It is not a good look if you set up a time and then you come and you're like, well, which one should I take? You should be telling me at that point. You should be like, I know I have this one missing. I have been studying for this one. All right. Um, so yes. And then the last day to turn in homework assignments will be next Wednesday. And the rounding at the end of the year for letter grades is as follows: zero point 0.5 rounds up. That's how rounding works. 0.49 will not round up. So my example is 79.5 is a B. It's an 80. So that's how rounding works. But 79.49 is a C. So that is that. Um, and then the last day of school is next Friday. So 5/28, just so you know. I mean, I'm sure you know, but wanted to throw that in there as well. And that is all. So, yeah.